Hello, 6th grade students, and welcome to the final lesson of this week's math concepts. Previously, we have looked at how expressions are equivalent to one another depending on their placement and how they are set up in a problem. Let's go ahead and open up our math notebooks, please. I'm going to do a clean sheet notebook paper, name today's date. Our objective today is I can evaluate algebraic expressions. So previously, looking at our warm-up problem here, I have 3 times x times x equals 3x squared. Is this equivalent? Yes, that is correct, because x and x multiplied together will give me 3x squared equals 3x squared. Now let's say we didn't want to do that. And the purpose of this kind of problem is to show that even not doing it this way, I can still prove that these are both equivalent expressions. Because let's say hypothetically that x equals 2. Now plugging in this equation now, the way I can write this is 3 times 2 times 2 equals 3 times 2 squared. Notice the only thing I did here was replace x with the value of 2. So now in going through our order of operations, 3 times 2 is 6, and 6 times 2 is 12. Looking on this other side here, using our order of operations, we always do exponents first, so 2 squared would give me 4, and 3 times 4 is what? You guys are getting too good at this. Yes, 12 is correct. So both sides of my equation would be the same value. Correct. Let's look at another example. Let's say I have 3 x minus y plus 10, where x equals 5 and y equals 2. What am I going to plug in for x? 5, correct. What am I going to plug in for y? Correct. So, in doing so, looking at our equation here, 5 minus y, which is 2, plus 10, all we did was take our variables and plug them in, and now let's solve using the order of operations. 5 minus 2 will give us 3, so now we have 3 times 3 plus 10. 3 times 3 is what? It's correct, 9. So 9 plus 10 is what? Correct. The answer is 19. Very good. Let's look at a few more. So, let's say I have 10x plus 2v minus s plus 12. Get a little saucy there. Where x equals 5, v equals 3, and s equals 7. Now, notice here that I'm changing up my variables a little bit. I'm using v, I'm using s. As we talked about before, with variables, variables can mean any type of number. You can put anything in these values. But for the sake of this problem, x is 5, v is 3, and s is 7. Let's go ahead and solve this now. So, 10 times x, which is 5, so 10 times 5, plus 2v, so 2 times v, which is 2 times 3, minus s, which is 7, plus 12. All right? Now, let's go ahead and do our order of operations. So, the first things first is what? I'm sorry? That's correct. Parentheses. 7 plus 12 is what? Right. 19. So now, 10 times 5 is what? 50. Plus 2 times 3, which is what? 6. So now we get the expression of 50 plus 6 minus 19. Now, As we've also talked about before, in terms of order of operations, you always need to do the expression going right to left when you're left with either multiplication or division or addition and subtraction. Because we have addition and subtraction left over in our bottom problem here, we're going to go left to right. So 50 plus 6 will give me 56. And 56 minus 19 is what? All right. Let's go ahead and go through it together. So, setting it up like so. 6 minus 9, can I do that? No, I cannot. So we need to borrow to create a 4, carry over to make it 16. 16 minus 9 is what? Anyone? Anyone?
7.
7, yes! Thank you! And 4 minus 1 is 3. Very good. So, 56 minus 19 is what? The answer is 37. Thank you very much. All right. So, going back to our objective of I can evaluate algebraic expressions, in your homework tonight, you're going to be asked to solve similar problems dealing with variables given certain values and looking for that final answer. Let's go ahead and complete our exit slip now. So, in doing so, let's say we have a cube. And we're trying to find the surface area of this cube. And the formula of this surface area of this cube is 6 times s to the third. Now, class, as we talked about before, what does it mean to be the third power? It means to be cubed, right. So it's going to be to the third power. So what I'm asking you to do for this exit slip is to find our surface area of our cube when s equals the following values. If s equals 2 inches, if s equals 3 inches, and if s equals, let's go 5 inches. Go ahead and pause the video now to go ahead and answer the following exit slip. All right, let's go ahead and solve it, shall we? So in looking at this, we now have 6 times, if I were to break apart s cubed, I would get 6 times s times s times s. So let's first go ahead with our problem A here with s equals 2 inches. So in doing so, I get 6 times 2 times 2 times 2. Well, 2 times 2 times 2, 2 times 2 is 4. 4 times 2 is 8, correct? So now we are given 6 times 8. 6 times 8 is what? 48. So the first answer for our surface area would be 48 inches squared. Because again, when we're dealing with surface area, we always leave our answer with our units, making it squared. Looking down here now, so 6, if s equals 3 now, well, let's see, 3 times 3 is what? 9, and 9 times 3 is what? I'm sorry, class, what is it? 27, which is correct. So now we're left with 6 times 27. Let's go ahead and do the math here. So 27 times 6. 6 times 7 is 42. And 2 times 6 is 12. Add 4 will give you 16. So the answer for this one is 162 inches squared. Now looking at our last problem, if I plug in now 5 into my equation, 5 times 5 is 25, and 25 times 5 is 125. Very good. So now I have 6 times 125. In doing our math, doing it up here, 125 times 6, 6 times 5 is 30. 2 times 6 is 12. Add a 3 gives us 15. 6 times 1 is 6. add 1 is 7. So our answer is 750 inches squared. So our answer for this is 48 inches squared for part A, 162 inches squared for part B, and 750 inches squared for part C. Join me next week when we look more at looking at variables and how they play into algebraic expressions. Stay tuned.